Hi everyone, this is your math guru. In this video, I'm going to show you how to factorize the following algebraic expressions by grouping in pairs and also applying the difference of 2 squared. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. We group in pairs when you have a polynomial with 4 terms and without any common factors. So if you look at the example given, you have yz squared minus y cubed plus z cubed minus y squared z. There's no common factor that is common to all the terms. So therefore, grouping in pairs, I'm going to group the first 2 terms on the left and the last 2 terms on the right. So what I have is, if you check the first 2 terms, I have y common. So therefore, taking out the common factor y from the first 2 terms, I'm going to divide all the terms, the 2 terms, by y. So I have y z squared divided by y minus y cubed divided by y. I have my plus. Then if you check the next term, the common factor is my z. So I have factorizing z, that the common factor. I'm going to divide all the terms in the bracket by z, which is the factor I took out, divided by z. So applying the laws of exponent, I have y in y that goes off, so I still have my y outside. Then I have yz squared divided by y. The y goes off. I'm left with z squared minus, applying laws of exponents, if the base are the same, you subtract the powers. So I have y3 minus 1. There's an invisible 1 here. So 3 minus 1 is 2. I'm left with y squared. I have plus z in bracket z cubed minus or divided by z to the power of 1. Laws of exponents, the same base. If you subtract the powers, I have z, 3 minus 1, z squared minus, then I have y squared z divided by z. The z divides each other. I'm left with yz squared. So therefore, if you look at what I have z squared minus y common to both sides. So that will be my common factor. So I'm taking out the common factor z squared minus y squared. Then I'm left with y and z. So I open the second bracket, I have y plus z. But I'm not done. If you look at the factors I have, z squared minus y squared, then y plus z, I can still factorize z squared minus y squared using the difference of 2 squares. So the difference of 2 squares states that a squared, if I have a squared minus b squared, it must be 2 terms, both perfect squared, separated by a minus. I have a plus b and a minus b. So applying that rule, my final answer will be, this time around my z is my a and my y is my b. So therefore, having my 2 bracket, I have a z, not a, z plus y z minus y, and my last factor, y plus z. Let's look at the next example. In the next example, I have y cubed minus y squared minus 4y plus 4. That's the polynomial with 4 terms. So grouping in pairs, I have my left-hand side and my right-hand side. So what I have is, I'm going to factor out y squared. I'm left with y cubed divided by y squared minus y squared divided by y squared, close bracket. On the right-hand side, I have plus 4 in bracket. I'm left with minus 4y divided by 4 plus 4 divided by 4. Note that I'm starting with a plus in the middle as shown, which is subject to change if the content of the bracket doesn't have the same sign. So simplifying, I have y squared in bracket y cubed divided by y squared. 3 minus 2 is 1, so I'm left with y1 minus y squared divided by y squared is 1. Then I have plus 4 in bracket minus 4y divided by 4, that's minus y, plus 4 divided by 4, 1. If you check the content of the bracket, even though the terms are y and 1, the signs are different. So therefore, on my left-hand side, I'm going to factor out -1. And factoring out -1 means the sign will change to a minus, and the content of the bracket on my right-hand side, all the signs will change. So I have y squared bracket y minus 1, taking out minus 1 times 4, that will make that -4, and then the signs will change. The minus y will change to plus y, and the plus 1 will change to minus 1. Now I have the same content in the bracket. That's a common factor to both sides. So taking out the common factor, I have y minus 1 in bracket. Then I'm left with, on my left-hand side, y squared minus 4. Note that y squared minus 4, that's difference of 2 squared because 4 is a perfect square. This is the same as y minus 1, y squared minus 2 squared. 2 squared is 2 times 2, which is 4. And applying the DOT, or difference of 2 squared rule, my final answer is y minus 1, y plus 2, y minus 2. That's an embedded factorization. Let's look at the last example. In my last example, I have x squared a plus x squared b minus ba minus 16b. I'm grouping in pairs. It's a polynomial with 4 terms without a common factor to all the terms. So therefore, on my left-hand side, I have x squared common. So factoring out x squared, I'll divide all the terms in the bracket by x squared. That's the factor. I have plus x squared b over x squared. I start with a plus to separate the terms. And if you look at the right-hand side, the common factor is 16. I changed, it was BA. I wrote the wrong question. It's 16A. So taking out 16, that's plus 16. I'll divide all the terms by 16. So I have minus 16A divided by 16 minus 16B divided by 16. That will be x squared. I'm left with x squared divided by x squared, that's 1. That's A plus B plus 16 in bracket. 16 divided by 16, that's 1. So minus A minus B. The content of the bracket, if you look at it, I have plus A plus B minus A minus B. To make the content of the bracket the same, I'm going to take out minus 1 on my right-hand side. And what that means is the sign in the middle will change. So therefore, I have that as x squared, A plus B, minus 16, because minus 1 times plus 16 will give you minus 16. And then the signs will change from minus A to plus A, from minus B to plus B. And if you look at the left-hand term and the right term, I have A plus B as a common term. So I take out A plus B as a common factor, as x squared minus 16. X squared minus 16, that's difference of 2 squared. So if I rewrite that, that will give me A plus B, x squared minus 4 squared. And therefore, applying the DOT, I have my final answer, A plus B, x plus 4, x minus 4. Thanks for watching. Bye.